Okay, guys, in this lesson, we're going to learn how to write and solve equations and inequalities with a single variable. So pretty much we're going to be looking at word problems, and we're going to look at a variety of word problems. So you may want to jot each of these examples in your notebook. So our example 1, it says half the sum of a number in 12 divided by 5 yields 2. And they want us to determine the number. Well, half the sum of, okay, is going to be 1/2 times. Now, sum of, anytime you see sum of, you're going to need to put parentheses around the following information. So it's half the sum of, and sum means to add, some number plus 12 divided by 5. The word yields means equals 2. So now we have an equation, and we're going to solve for x to see what the number is. It's like a puzzle. So here, before we start solving, we need to distribute this 1/2. So we're going to have 1/2 times x, and 1/2 plus 12 is plus 6, all divided by 5 equals 2. So again, we're trying to solve for x, our missing number, and so x is being multiplied by 1/2, then we're adding 6, and then we're dividing by 5. So if we knew the value of x, that's what we would do with order of operations. But we're solving, so we're going to go backward, and we're going to do the inverse of each of these. So we're going to get rid of the division by multiplying both sides by 5. This gives us 1/2 times x plus 6 equals 10. Now we need to undo the plus 6 by subtracting 6. So check that off. We have 1/2 times x is equal to 4. Now we need to undo the times 1/2. So we're going to multiply both sides by 2. So multiplying by 1/2 and multiplying by 2 are inverses, or we could say dividing by the 1/2. So when we multiply both sides, we get x is equal to 8. That is our missing number. Example 2. Josh is 3 more than twice as old as Callie. The sum of their age is 60. How old is each person? So we're going to have to establish what variable we're going to use, because we can only use one variable. If we have 2 unknowns, then we won't be able to find either one in this situation. So let's come up with a formula. We're given that the sum of their age is 60. So if we knew Josh, so this is kind of my formula, plus Callie equals 60. So this is my formula. Josh plus Callie equals 60. Now we need something to represent Josh, and we need something to represent Callie. So let's establish what our variable is going to be. Josh is 3 more than twice as old as Callie. What I typically do is the part I know the least about is the variable I'm going to use. So I know a little bit about Josh. I really know nothing about Callie. So we're going to let C represent Callie. So C is going to be Callie. Now we're going to take the C value to represent Josh. So we have to establish some kind of expression using C to represent Josh. Josh is 3 more than twice as old as Callie. So twice Callie would be 2C. And then we have 3 more than that. And this is going to equal Josh. Now, remember, 3 more than is a flip-flop phrase. So that's why I switched the 3 more than with the twice. So the 2 times comes first and the plus 3 comes second. So now we have established each of these people as an expression. So now we're just going to plug in. For Josh, we're going to plug in 2C plus 3. This represents his age. That's Josh, plus Callie, which is just C, equals 60. I'm going to put this in parentheses, or I'm saying quotes. Now, see how we have one type of variable? That's what you want. You don't want a C and a J You want one type of variable. So now we're just going to solve. So we're going to collect like terms. So we have 3c plus 3 equals 60. We're going to subtract 3 from both sides. We're going to divide each side by 3. And 3 goes into 57. So 3 goes in once. So that looks like 19. Let me just double check myself. Yes. Now Callie, C is 19. So Callie is 19. Now to find Josh, we're going to plug in 19 for C to get Josh's. So 2 times 19 is 38 plus the 3, that gives us 41. So Josh is 41 years old. And if we were to add these up, we would indeed get the 60. Callie is 10 years less than 3 times as old as Amber. Lydia is 14 years more than half as old as Amber. The sum of their age is 58. How old is each person? So this time we have 3 people. So we're going to say Callie plus Lydia plus Amber equals 58. Now we need to represent each Callie, Lydia, and Amber using one common variable. So which of these do we know nothing about? Callie is blah, blah, blah. So we know something about Callie. Lydia is blah, blah, blah. We know something about Lydia. They're both being compared to Amber, and we know nothing really about Amber. So let A be Amber. Now we're going to compare, and let's represent Callie. Callie is 10 years less than, so we're going to flip the minus 10 to the back because less than is a flip-flop. 3 times Amber, which is A. So 3 times A minus 10 is going to equal Callie. Now let's look at Lydia. Lydia is 14 years more than half as old as Amber. So we're going to have half of Amber plus 14 is going to equal Lydia. Now we have an expression for each of these 3 individuals. So we're going to plug these in. For Callie, we have 3a minus 10. Our formula says to add. We have Lydia, which is 1/2 a plus 14, plus Amber, which is just a, and it equals 58. Now let's collect like terms. We have 3a and 1/2 of an a and 1a. So that's going to be 4 and 1/2 a. We have minus 10 and plus 14. That's going to be plus 4 equals 58. Now we're going to subtract 4 from both sides. I'm going to go ahead and just convert this into a mixed number. I'm so sorry, it is mixed into improper. So 2 times 4 plus 1 is 9/2 a equals 54. Now I'm going to multiply both sides by the reciprocal. So 9 goes in 54, 6, and 6 times 2 is 12. So Amber is 12. Callie is going to be, let's come down here. Callie is 3 times 12 minus 10. So 3 times 12 is 36 minus 10. That is going to give us 26. And then we have Lydia. We're going to have 1/2 times 12 plus 14. So half of 12 is 6 plus 14 is 20. So I'm going to put it right here. And again, if we were to add these up, we would indeed get the 58. A rectangle has a perimeter of 108 units. The length is 6 less than 4 times the width. Determine the dimensions of the rectangle. Okay, so the dimensions, we just want to know the length and the width. So our formula for this is perimeter equals 2 lengths plus 2 widths. Now we need to establish we're either going to use an L or a W. Again, we can only use one type of variable. So we know something about the length. The length is 6 less than 4 times the width. So we know nothing about the width. So let W equal width. Now we're going to take this W to represent and express the length. So we're going to use W, 6 less than, that is a flip-flop, 4 times the width. So that's going to be 4W minus 6 is going to be the length. So we have established our representations for each dimension, and now we're going to plug it into the formula. So we know the perimeter is 108, so we're going to plug that in. 2 times the length, our length is 4W minus 6. So we definitely need parentheses plus 2 times W. So I have all the same type of variables. So now we're going to solve by distributing. Then we're going to combine like terms. Now let's solve. Add 12. So this is going to be 120 equals 10W. We're going to divide, and we're going to get the measurement of the width. So W, which stands for width, is going to be 12. We're going to plug in 12 for W to get the length. 4 times 12 is 48 minus 6 gives me 42. So on our rectangle, we have a width of 12 and we have a length of 42. And if we were to add all of these around, we would get 108. The sum of 3 consecutive numbers is 216. So consecutive means one after the other. The sum of 3 consecutive numbers is 216. So here's how we're going to establish this. Let X equal the first number. Then, if you have X and you want to get to the next number, you would just add 1 to it. So let X plus 1 equal the second number. And then if you were at X and you wanted to get to the third number, you would add 2 to that original first number. Now, I forgot to write our formula down, so let's do that. So our formula is going to be our first number plus our second number plus our third number is going to equal 216. And I'm using plus because it says the sum. Now let's plug in each component for each representation. So X plus 1, and our third number is X plus 2 equals 216. Let's combine like terms. 3X plus 3 equals 216. Subtract 3. And divide by 3. So 3 goes into 21.7 and into 3.1. So our first number is 3. I'm so sorry. Is 71. And then our next number would be 71 plus 1. So, and we're doing consecutive numbers, so it's right in a row. So 71, 72, 73. And if we were to add these up, we would get 216. The sum of 3 consecutive odd numbers is 279. So this time we're going to have our first number. Let's undo that. We're going to, let's do our formula. So we're going to have our first number plus our second number, but it is going to be, these are going to be odd, plus our third number equals 279. So again, let's just start and let X equal our first number. Now, To get the second number, you're not just going to add 1, because if we only want odd, let's just say that I'm at the number 11. The next consecutive number that's odd is going to be 13. So to get from 11 to 13, you're going to add 2. 11 plus 2 gives me that 13. So we're going to say x plus 2 will give me the next odd number. Okay, then if I want to go from 11 to 13 and then to the next odd number from 11, which is like our x, from 11 to 15 would be plus 4. So let's let x plus 4 be our third number. So sometimes when I'm doing word problems, I'll just make up some number and then just think about what is the process I'm going to use if I actually knew an actual number or value or expression. So that's just my little thinking over here. So from here to here is plus 2, and from here to here is plus 4. So that's where these comes from right here. So now let's plug it in. We have our first number, x, plus our second number, x plus 2, plus our third number, x plus 4 is equal to 279. Let's combine and solve. So this is going to give me 91. So our first number is 91. Our next consecutive odd number is 93. And then our third number is going to be 95. Jack has earned 88, 96, 91, 86, and 93 on his first 5 algebra tests. What is the lowest grade he needs to make on his midterm to reach his goal of a 90? So we know that the average, so let me show you a new notation. This means average. X bar, that means average. So we know that we're going to add up all the test scores. So like our first test plus our second test plus our third test, dot, 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 all over n, which is the number of tests taken. So we know that X1 is going to be 88. X2 is going to be 96. Our third test is 91. Our fourth test is 86. Our fifth test is 93. And we want to know, I'm just going to leave it as X, what does this last test needs to be to have an average of 90? So we're going to use a less than or greater than to say what is the least amount. Like if he makes this or more, he will meet his goal of a 90. So we are going to plug in and we're going to say 88 plus 96 plus 91 plus 86 plus 93 plus some other test grade, all divided by 1, 2, 3, 4, 5, and 6 tests. And we want this to be equal or more than, so we can make a 90. So now we need to add up these grades, and in this unit we can use a calculator. So I'm going to add these up. 88 plus 96 plus 91 plus 86 plus 93 gives me a total of, so I'm just going to bring this down, plus the next test grade, all divided by 6, is greater or equal to 90. Now we are solving to find out what x needs to be to meet my goal of 90 or better. So we have to multiply both sides times 6. Plus x is greater or equal to, so 9 times 6 is 54, plus the 0, I'm going to subtract out 454, and x needs to be greater or equal to, and that looks like that's going to be 6, I believe. Let's do this just to double check. I don't want to have to redo this. Yes, 86. So he needs to make an 86 or better to make a 90 for his final average.